Okay, so for this video, we are going to be looking at the review for Unit 5, specifically at numbers 24 through 27. So on all of the problems, it says to write the correct quadratic equation for each transformation. Okay, so for all of these problems, I'm going to be using two different colors of pens. Okay, and so my parent function, which is my f of x, equals x squared, I'm going to be using purple. And for my new function, I'm going to call all of them for each of the problems g of x. And that just means, if it's in red, it just means that it's part of the new, or part of the transformation. Okay? So, number 24, it says to give two different examples of the quadratic parent function being reflected across the x-axis. So, if you remember, in order to reflect a function across the x-axis, you have to make it negative. So, in order to do that, we have our new function g of x. That is going to be equal to making our old function f of x, our parent function f of x, negative. Okay, so now that I have negative f of x, all I need to do is plug in the x squared. So I'm going to do this step by step, so hopefully no one will get lost. So that means negative x squared. So g of x is, g of x is negative x squared. So that takes the x squared parent function and the negative flips it, or reflects it across the x-axis. All right, so now we're going to do another example. Now there's actually an infinite number of examples that we can use here, but I'm just going to choose a simple one. So in this case, our second example, we're going to use g of x again. We still need to make it negative, but let's just pick another negative number. So let's just use negative 4. Okay, so we're going to multiply our parent function f of x by this negative 4. And as long as we multiply by a negative number, it will reflect across the x-axis. And then, so negative 4. And then now instead of writing f of x, we're going to substitute that x squared in there. So our new, after the transformation function, g of x is equal to negative 4x squared. And because it's negative now, it reflects across the x-axis. Okay, so for 25, we have two different examples that we need to use. It says to write two quadratic equations where the parent function is translated. For the first example, it's going to be up 11 units. So hopefully you remember, whenever you translate up 11 units, you have to add 11 outside of the parentheses. So our new function, g of x, is going to be equal to our parent function, f of x, plus 11. Okay, so in order to write it with the x squared in there, we just need to plug in x squared where that f of x is. So now we have x squared plus 11. So our new function, okay, is our parent function shifted up 11 units. So that's x squared plus 11. All right, so in order to shift down 11 units, we're just going to do the opposite. So instead of adding to shift up, we're just going to subtract to shift down. So start with the g of x for our new function. That is equal to our parent function, f of x, minus 11. So basically it's telling you take the parent function, shift it down 11 units. Okay, and that will give us, once we plug in the x squared minus 11. Okay, so 26, two examples on that also. It says to write two quadratic equations where the parent function is translated to the right 7 units. Now, if you remember correctly, these are a little bit tricky. Whenever you're shifting right and left, the signs are opposite of what some people think that they might be. So if we're going to shift to the right, we actually have to subtract 7 units. So how that looks, okay, so our new function, g of x, is going to be equal to our parent function, f of x. Now I'm going to leave some space here, because when you're shifting left and right, you have to put it inside the parentheses. So if it says shift right, I'm actually going to subtract 7 units. Okay, so the correct way to write the answer is going to be parenthesis x minus 7 inside the parentheses squared. So you're telling the function to start at the parent function of x squared, but you're subtracting 7, which shifts it to the right. All right, so same idea on this one. Our new function, g of x, is going to be our parent function f of x. Now this time we're going to add 7. So in order to shift left, we have to add 7 to our parent function inside the parentheses. So the final answer should look like parenthesis x plus 7 parenthesis squared. So parent function, and then the plus 7 tells you to shift it to the right. Okay, last problem. What is the effect on the quadratic parent function f of x equals x squared, and I've been using purple for this, when g of x equals a times f of x? Okay, so if you remember, these, whenever you multiply by the parent function, or by a value before the parent function, it is either going to get more steep or less steep. Basically, it's going to make it either fatter or thinner, right? So when a is greater than 1, that's any number when a is greater than 1. That's 2, 3, 5, 10,000, infinity, any of that, okay? So your new function, g of x, we're just going to keep it simple here. We're just going to use number 2, is going to be equal to 2 times the parent function. Okay? And then that is going to look like 2 times x squared. So this is all it's really saying, is to just multiply by a number larger than 1 and outside the parentheses. Okay? So whenever a is between 0 and 1, you're really just looking at a fraction, okay? A fraction that's between 0 and 1. We're going to keep it simple and use the fraction of 1/2, okay? So g of x equals, okay, and remember a times f of x right here. So our a in this case is going to be 1/2 multiplied by our parent function, f of x. So it's just going to look just like that, except for we're going to plug in the x squared there. So our final answer is 1/2 times x squared. So g of x equals 1/2 x squared on that last one. Great, so hopefully the step-by-step helped you to kind of understand what's going on here. Just talk to your teachers. If you need any more help, make sure you come to tutoring.